Hey guys, I am not in class today because I'm proctoring for the FSA retake. So don't worry, you will still get your fancy book learning. Your assignment for today is just to watch this video and then fill out your notes. We will finish this packet and then you guys will be set for doing your homework assignment. When I have a substitute, the assignments count double. So this is going to be two classwork grades, which is going to be the same as a quiz grade technically. So it's important that you take the notes, fill them out. If you have it done by Monday, when you're in class next, you'll get full credit. If you don't have it done then, the most you can get is a 50 by getting it done on Wednesday. If you don't have it done by Wednesday, it stays a 0. I'm serious about it, no exceptions. It's important that you guys take responsibility for your learning. So pay attention. I will have tutoring Monday after school from 2 to 3 o'clock, and then your test is on Wednesday. And on Monday, we will have a big review day in class. All right, so let's go over these. Excuse me. Segment AB is formed by point A and point B, and it gives the coordinates for those. If line L is the perpendicular bisector of segment AB, write a linear equation for line L in slope-intercept form. So let's plot this and see what's happening. -1, +4, and 5, 1, 2, 3, 4, 5, -2. All right, so there's our segment AB. Let me try to zoom in. There we go, that's better. Line L is a perpendicular bisector. So just as a reminder, a bisector cuts something into two equal pieces. If you dissect something, it cuts it. To bisect it means you cut it in two, and it's two equal pieces. So how can we look at a segment and figure out the point that's going to be in the middle that is going to cut it into pieces? This is referencing some knowledge from Unit 1. If you need the point in the middle, that would be using the midpoint. So the formula for midpoint is finding the average of the x's. You add the x's together, divide by 2, and then find the average of the y's, add the y's together, divide by 2. So this is, let's see, -1 plus 5. Those are my x values, and divide that by 2. And then my y values, 4 plus -2, divide by 2. My x values, my y values, adding them together, dividing by 2. So this is 4 divided by 2. This is 2 divided by 2. That simplifies to 1. So plotting that is 2, 1 right there. Made a pretty good guess as to what the center would be. This is the midpoint of the segment. So if we have a line that goes through here and perpendicular, that's one of the keywords we need to look for. It intersects it at a perpendicular angle. Perpendicular is a 90-degree right angle. So how can we find perpendicular? If you hear perpendicular, you should think slope. So we need to figure out the slope of this segment. So I'm going to use rise over run, and we're going to count down 1, 2, 3, 4, 5, 6. So the slope of segment AB, -6, because I'm going down, that's a negative movement. And then going to the right is positive, 1, 2, 3, 4, 5, 6. So the slope of this line is -6 over 6. That can simplify to -1. All right, but we now need to think about this line. It's going to be perpendicular to that. So looking back at your notes, where did we talk about? Perpendicular. On page 2, we talked about what it means to be perpendicular, opposite reciprocals. So we change the sign and then we flip the numerator and denominator. Well, this, we simplified it to just 1. We can always put it over 1 if you want. If you flip 1 over 1, it just becomes 1. But we also have to change the sign. So the new slope of our new line, it's going to say M, and then that's the symbol for perpendicular, it's going to be +1. We change that sign, and then we flip 1 over 1, which is just 1. All right, so we know a point that this line goes through. We know the slope. So now we can plug that into point slope formula, which we talked about last class, and plot that and see what, or plug it in and see what that equation is going to be. All right, so y minus, my y1 is 1, equals m is 1 times x minus x1 is 2. Today someone was asking me, why are these minus? That's just the equation. The equation says y minus y1. So if you want to think of it as this minus means the opposite, take the opposite of the y. That's positive, so this one's going to be negative. Take the opposite of that x. This one's positive, so we're going to make that negative. If that helps you thinking of it that way, that's how the equation works. All right, so the left-hand side, it's just y minus 1. We distribute the 1 to each of those. We're multiplying. Well, multiplying it by 1, that's really easy. It just stays x minus 2. And now we want to move the 1 to the other side to eliminate it on the left. Y equals x minus 1. So it's crossing the y-axis. This is the y-intercept at -1. You could, from this point, if you know it has a slope of +1, you can plot more points. You know you're going to go down 1, left 1, down 1, left 1. And then when you get there, you're on the y-intercept, on the y-axis. So that would be your y-intercept. So if you wanted to use that method instead of doing this work, you can. But you won't always have a coordinate plane, so you need to understand how to do it mathematically. So we would draw that line. Anytime we have a slope of 1 or -1, we're going to be hitting the corners of these boxes just to make it easier for you guys to graph. That's a little trick. All right, so that's line L. All right, now line XY, or segment XY, formed by these 2 points. Line J, perpendicular bisector, write a linear equation in slope-intercept form. Same process. Okay, so -9, -7. 1, 2, 3, 4, 5, 6, 7. This is x. Y is -3, +5. 1, 2, 3, 4, 5. All right, so that is segment XY. And we need to figure out where the perpendicular bisect is going to intersect, and we are going to use the midpoint formula for that. So add the x's together. -9 plus -3, divide by 2, and then -7 plus 5, divide by 2. Those are the y's. All right, so -9 plus -3, that is -12. And we divide that by 2. -7 plus 5 is -2. And we divide that by 2. This simplifies. -6, -1. So 1, 2, 3, 4, 5, 6, -1. That is the midpoint. So our bisector is going to hit right here. It's going to be perpendicular, so look something like that. It's going to make a right angle right there. But to know what the slope is, we have to figure out what the slope of this one is. So you can use the y2 minus y1 over x2 minus x1 if you don't want to count all these little spaces up and over. I'm going to do that just as practice. If you want to count up and over, rise over run, that will work too. So y2, I'm going to use -7 minus 5 over -9 minus -3. So this is -12 over, that turns to plus -6. So this is a slope of 2. This segment has a slope of 2 or 2 over 1. We need the perpendicular slope, so we need to change the sign. This is positive, so our perpendicular slope will be negative, and then we flip it. So we take the reciprocal of 2 over 1, which is 1 over 2. All right, so now we have a point, we have a slope, we can plug it into point slope form. Or you can, from this point, plot other points with a -1 over 2 slope and see where you're going to cross the y-axis. So we'll go down 1 over 2, down 1 over 2, down 1 over 2, and there we land on the y-axis. So this is at -1, 2, 3, 4. So our y-intercept, we use the letter b for that variable, is -4. Some people asked, well, how do you know that you're going down and then right? Why not down and left? Well, when you go down, that's a negative movement. If you're going down on the number line on the y, that's going negative. And then when you go right, that's positive. We need one negative and one positive, because if you do a negative and then a negative, that's going to end up, what's a negative divided by a negative? That's a positive. So we need one negative, one positive, one negative, one positive, one negative, one positive. And that one puts us on the y-axis. So this is y equals m -1/2 times x, and then b is -4. I forgot to draw this line, so here we go. And that is line J. Okay. Now let's talk about quadrilaterals. Quad means 4. You guys probably know that. So a quadrilaterals are 4-sided figures or 4-sided shapes. All right, we're going to have a couple sections on polygons. For now, we're going to talk about quadrilaterals pretty basically. All of them that we're going to talk about right now are going to be parallelograms. A parallelogram has 2 sets of congruent sides. Not congruent, I'm sorry, 2 sets of parallel sides. Two sets of parallel sides. Okay, so all of these shapes, squares, rectangles, and rhombuses, they're all considered parallelograms. So we're gonna, when we get to polygons, I'll show you guys a family tree of, okay, these are parallelograms, and then the little branches down from parallelograms are these. But for now, we're going to classify shapes as parallelograms if they're not one of these. So we're going to use the process of elimination to determine if they're one of these or a parallelogram. All right, so let's start with squares, because you guys probably know a lot about squares. Geometry, you guys are like, geometry is so hard. Well, now we're talking about shapes, and you guys know a lot about shapes, right? You've been working on those for many, many years. All right, so squares have 90-degree angles. They are right angles. That is not new information for you guys. What do we know about right angles? Well, they are going to be have perpendicular sides. Like this angle right here, this is a right angle. So they have intersecting sides that are perpendicular. So the intersecting sides are going to be perpendicular. And just as a reminder, what does it mean for them to be perpendicular? Well, the slopes will be opposite reciprocals. So we can use some information about the slopes of the sides. intersecting sides, perpendicular, and then let's just put parentheses slopes there because we're going to need to remember that we can check to see if they're perpendicular by using the slopes. All right, what about the opposite sides? Opposite sides are parallel. That's a symbol for parallel. It looks like an 11. It's a set of parallel lines. And they are going to be congruent. Opposite sides parallel. And speaking of sides, all of them are going to be congruent. We know squares have 4 congruent sides. So congruent sides. The parallel, to be parallel, they're going to have different slopes. Or excuse me, same slopes. What am I talking about? Same slopes. Okay, now if we take a square and we have a square and we tip it over like that, that becomes a rhombus. So we have the sides are the same length. So we still have intersecting sides. We have opposite sides. The opposite sides are still going to be parallel, but the intersecting sides this time are not going to be perpendicular because we're changing that angle. So the angles are not 90 degrees. They do not have 90-degree angles. When we take that square and we tip it, we're going to change that angle, not 90-degree angles. So the intersecting sides are not going to be parallel. Excuse me, intersecting sides are not going to be perpendicular. Just getting all my words mixed up. Okay, opposite sides will be parallel. Opposite sides are still going to be parallel. And those sides are still going to be congruent. So we have changed the angle of those corners. And when we do that, we've made them not perpendicular. So you can check the slopes to see if they're perpendicular or not. That would distinguish between squares and rhombuses. And you might say, well, can't we just look at it and tell? Nope, not always. You have to verify. Okay, so now let's talk about rectangles. Rectangles and squares, very similar. They both have 90-degree angles. They have intersecting lines that are perpendicular. Again, we can check the slopes. And the opposite sides are parallel. The thing that's different is it doesn't have 4 congruent sides. A rectangle has 2 pairs of congruent sides. All right, so let's say we have a rectangle and then we tip it. Now it's a parallelogram. So same thing when we had a square, we tipped it, we changed the angle. So a parallelogram does not have to have 90-degree angles. It can have 90-degree angles because all of these are considered parallelograms because what makes it a parallelogram is it has 2 sets of parallel sides. All of these do. This is going to have 2 sets of parallel sides, 2 sets of parallel sides, 2 sets of parallel sides. So we're going to use the process of elimination. If it has 2 sets of parallel sides but does not have those 90-degree right angles, then we're going to call it a parallelogram. All right, so now let's determine if this is a square, rectangle, parallelogram, I should say rhombus, or neither. Okay, so we can look at this. This usually in geometry, in math, I say don't assume. Don't go based upon what it looks like when it comes to figures because it's not to scale. Well, this is on a coordinate plane, so there is, we can look at it and you can tell that this side is much shorter than this side, right? That's Captain Obvious there speaking. So we can rule out it being a square. And because it does not have 4 congruent sides, we can rule out a rhombus. But now we have to decide, is it a rectangle or is it a parallelogram? Well, what's the difference between those? Both of them have 2 sets of parallel sides. The thing that differentiates them is the angles. Are they perpendicular or not? So how can we check that? We're going to use the slope formula. So let's look at the slope of segment EP. We're going to go from E to P, down 1 over 1. This down is negative, and then going right, that's positive. So this has a slope of -1. The slope of EN, segment EN, we're going to go up 1, 2, 3, 4, 5, 6, 7, up 7, so that's positive, and then over 1, 2, 3, 4, 5, 6, 7, 8, 9, and that's going to be positive as well. So this has a slope of 7 over 9. Is -1 the opposite reciprocal of 7 over 9? Well, they're opposites. One's positive, one's negative. But if you flip 7 over 9, you do not get 1. You can't simplify this to make it 1. So these are not perpendicular, so not a rectangle. So that's going to make it a parallelogram. And if you were to turn this, you could look at it, and if you turn it like that, you can see it's shifted just a little bit, tipped over just a little bit, really close to being 7 over 9 is really close to 1, which would be the opposite reciprocal of -1, but not quite there. And we have to verify mathematically, so that's what we did here by checking the slopes. Okay, so the next one for quadrilateral jump, JUMP, we need to plot this 2, 2, that's J, U is 0, 10, M is 8, 8, and P is 10, 0. All right, so let me connect those. All right, straight-ish lines. Okay, so just looking at it, is it a square or a rectangle? Can you tell right away those are not 90-degree angles? Yeah, you probably can. If you needed to verify, you could use the slope, but since we can look at that and these are obviously much smaller than these angles, we haven't even talked about angles yet, but you can tell those are not 90-degree angles. So let's eliminate square and rectangle. So now we need to decide, is it a rhombus or is it a parallelogram? All right, so the difference between these is a rhombus has congruent sides. A parallelogram does not necessarily have congruent sides. So we need to look at the length of those sides. So you can use the distance formula. That will work. It is kind of long. And for those of you who like to use that, there are more errors, more chance for errors because there are more steps with like minus negatives. So I recommend using Pythagorean theorem. So if you make the sides of this shape the hypotenuse of a right triangle, you can use Pythagorean theorem. So if that's the hypotenuse, we would say this is a right triangle, and this side down here is 2 units long. This side here is 8 units long. You can count. I've already counted. This is not my first time going through these notes. So you can trust me. You can verify if you want. This is 2. That's 8. So we could find the length of this segment is 2 squared plus 8 squared equals c squared. C is the hypotenuse. That's 4. 64 equals c squared. This is 68 equals c squared. But we want to know what c is, not c squared. So we take the square root of both sides, and we find that the square root of 68 is 8.2. So this is 8.2. That's the length of that side. And you can use the same process to find the length of each of these other sides. But there's a shortcut. You can do all this math. That's fine. Great if you want to. But if you were to say, all right, I'm going to make this a right triangle, and that's a hypotenuse. This side is going to be 2. This side is going to be 8. Again, you can count and verify, but you're going to find those numbers. Make this the hypotenuse of a right triangle, and this the hypotenuse of a right triangle. For each of those, this side is 2, that side is 2, this side is 8, that side is 8. So if you have triangles that have legs that are 2 and 8, 2 and 8, 2 and 8, you can plug it in to the Pythagorean theorem 3 more times. You're going to get the same answer every time. So if you are trying to verify if these sides are the same length, check to see what the legs of that right triangle are. If the legs are the same length, then the hypotenuse is going to be the same. So the sides of that this shape are going to be the same. So if we have 4 congruent sides, is that a characteristic of parallelograms or rhombuses? Rhombusi? I'm not sure what the plural of rhombus is. That's going to be a rhombus. It's a square that we have squished over. So 4 congruent sides, that is a rhombus. There you go. So for your homework assignment, your homework I put on the table when you first walk in. That first sheet, there are 2 stacks of papers there. The first one is your homework assignment. You're going to have some quadrilaterals where you have to verify the distances around. You're going to have to tell if they're parallel. How do you tell if they're parallel? Well, you can check the slopes. You have to tell if they're perpendicular. How do you do that? Check the slopes. You have to verify if the segments are congruent. How do you do that? You can use Pythagorean theorem or this little cheat version of it just to see if those hypotenuses are the same length. And then there's one that asks about the diagonals. So let me see if I have one here. I think I forgot to bring one home with me. If you have to verify the diagonals go from one corner to the other. That's probably something you already know. Number 3 on the homework. I'm going to redraw it over here. Let's see. I don't remember what it looked like, but it's some sort of shape. We'll say it's like this. If you have a diagonal there and a diagonal there, you have to tell if they bisect each other. So find the midpoint of each of those segments. So this point and that point. Find the midpoint of this segment. And then this point and that point, find the midpoint of that segment as well. If those midpoints are the same, they will bisect, those segments will bisect each other. One of the segments will have to hit the other segment at the midpoint. if same midpoint, they do bisect each other. All right, number 4, it is, I think, more of a diamond shape, like that. And when you draw the diagonals, you're drawing along a vertical and horizontal line. So that one is really easy because you can just count to see how many units are on either side. I think it's something like that. So you can tell me based upon counting if they are intersecting at the midpoint. So for each of those, you don't have to have a ton of work shown on your homework. Just kind of jot some notes to explain, like tell me why. Sides are congruent, why? Because the hypotenuses, or like show me that you're figuring out that the legs of the triangle are the same for each of those triangles. Something like that, okay? There's another stack of papers on that table, and it is the study guide. That will not be for a grade, which I know means most of you will not do that. But if you want to, it would be great practice. If you can answer those questions, you're going to do great on your test. I will give you the answers to that on Monday. We'll go over some of those and we'll do a review game. Let me know if you guys have any questions via email or remind, and behave yourselves for the sub.